Hello, my name is Joseph Owens, and this is a project from my third year at university. So what is it? Uh, it's basically an image recognizer that uses a KNN, nearest neighbor algorithm, uh, which we had to implement ourselves in a sort of Java program. So I'll go through what we have. We sort of have an executable for the program, and these are the images and things. Let me just unzip that real quick. There we go. So the data to train on comes in these bin files, and there was a specific way to decode these into the data. So this is the CFAR10 data set. Let's get the program started. You run it by here. I'll drag it over. So it's pretty simple swing UI components. Not really stacked too well, but it's more for the functionality in this project. So I can add some of these to this, and this is the training page. So if we set that, that trains it up. We can then open another one. Maybe use our file selector. Go into our data and find another one. So you've got two sort of options for opening data, so we'll just use two. And you're greeted with this nicely stacked home page. And you've got two kind of options. You can either evaluate the model performance, or you can classify a single image. So the CFAR10 is a bunch of little images. Take a look at one. Little tiny 32 by 32. Looks like an airplane to me. Where the sort of in these are the ones to test. You can see they've got the class is sort of the first thing. Each one relating to the metadata, the labels. So if I want to classify an image, I can open it up, go into that folder, can look at the test images, and we can attempt to classification. And that it thinks it's a deer, but it's an emu. And that's because it's the nearest neighbours. Which isn't the most accurate thing for detecting images, but we can change the number of nearest neighbours here in the algorithm, and you can see it still thinks it's a deer. Should we try another one? Test images. Let's go for the go a bit further. Let's go that one. Set. And it thinks that truck is a bird. So that's how that works. Then you can also evaluate the model. You can open up one of the data sets. Let's go back into. Give me a second. So we loaded number 1 and 2. We could put the whole folder of test images in there. That should work. Set that, and you can see it starts evaluating the model, so it'll give us the model's accuracy at the end. You can see it's going along pretty well. If we take a look at the performance, you can see it's all using all of that core, and it is multi-threaded. So we can take a look. All of our cores are going ballistic. And it's going pretty fast. So, yeah, it's an interesting challenge. It uses the Java Streams library, because we tried to implement a lot of the modern stuff that was added in the Java updates. It's really interesting seeing the sort of thing all these newer programming languages have sort of brought along with them. Sort of like how sort of different you can program things these days. So it got an accuracy of 0.35, which is not too bad considering there's 10 classes. So the random accuracy would be 0.1. So it's slightly better than randomly attributing a label. So let's jump into the source code. And here is the source code. So we're on the in point, which just starts a app controller. So this project required us to use model view controller design pattern. So views are like pages, like the sort of UI design of it, and then the controller will put the functionality, and then model is sort of where data is stored across the program. So we're on the app controller here, and you can see the pages are the views, and these are the controllers, and each page is a view and has its own controller. This app controller is a singleton. When it starts up the program, initializes our pages, all of them at once. Because it's quite a small program, you can just load the whole thing, and creates the controllers for them. And something I've not really done in Java before this was passing like these anonymous functions through, and we do that quite a bit. So it's interesting working like this in Java. I didn't really know you could do this, but with all the updates and things, you really can. And so it's pretty simple when it starts up. When you just want to go to a page, it just changes the window content to the view. The controller's been initialized and everything. There's not much to do. And yeah, so following that sort of idea, we've got our views, and here they are down on the right, all of our different views. And so when you open up one of these, you've got sort of the components of the program. So so this is a train page. This is sort of one you open to. Where'd my program go? It's programming, and open the chart. You can see we've got our file opener panel, which is its own component. It's sort of like a generic sort of thing. So it's got like a label, it's got a file path, open and set, and these all have these functions in them that basically allow the controller. These are public, so the controller can set a function for it. which it does. And this train page is sort of, again, it's the same thing. So we go into the controller for the train page. Should be up here somewhere. You can see in the main code, all it does is it gets past its page and it sends it the functions that it wants to execute. So you can see sort of that file opener, and the train calls up the model, I believe. It should somewhere. Oh yeah, it creates datasets here. Datasets are sort of their own objects, and this is part of the model, I believe. Oh no, this is the controller. Here's the. We've got our classifier. Is this going to the? So it sort of trains it up. When you sort of train a nearest neighbour's algorithm, what you do is you just store the images, and you when you get a new data point, you just put that data point, compare it to all the other ones, and find the ones that have like data that are nearest, and then so you check the distances, mathematical differences in the pixels. You find ones that are near, and we then sort those. We find the closest images, and we return which one's the most common, and also like the confidence as well. That was like the 3 out of 5. And another part of the program is sort of these actually loading the dataset. So there were sort of two ways we had to open a dataset. We had those folder of labeled PNGs, and we had those bin files, which you can sort of turn into a group of images. So there's sort of two different functions we need, and I basically built a function that'll do both. So first of all, it just sees if it's like a folder, and if it is, it'll just load it from PNGs, and if not, it loads it from binary. So with the sort of binary, we had to look into how that sort of all works. We had to learn the sort of format, and the way mine does it is it turns it into uses like the uses the color library, I think. Creates a buffered image. Uses reading bytes there. And it loads the whole image in, setting RGB, and then it adds it to the list of labeled images. And sort of labeled images are these functions, so you've got the label and the image basically. And it works pretty well. You can see it sort of was either to load either just the folder or the binary file. So yeah, we had to learn about images, and we also looked at like modifying the image to make it better to classify. But in the end, I found that it was both faster and most accurate when you just fed it the sort of raw image, and you didn't grayscale it or anything. You just used RGB, using streams to make it multi-threaded. And yeah, I'm pretty happy with it. So that's that project.